This is a walkthrough of Problem 1 on Exam 2 of Module 2 from the book Problem Solving Guide for Mechanics and Thermodynamics. Problem 1. A baseball is thrown horizontally from the top edge of a tall building. The ball hits the ground moving 50 meters per second 4 seconds after it was thrown. How high above the ground was the baseball thrown? What is the initial speed of the baseball? At what height above the ground is the speed of the baseball 40 meters per second? Let's start with a nice diagram. There's our building. The baseball is thrown horizontally. Hits the ground going 50 meters per second 4 seconds after it was thrown. There's the y, the height, and the x, the distance away from the base of the building it hit. Now let's think. How high above the ground was the baseball thrown? We have very little information here, and it's very tempting to stick that 50 meters per second into some equation. If you love to plug stuff into equations, you're going to be using that 50 meters per second. But that 50 meters per second is not in the x direction, and it is not in the y direction. It does not belong in any physics equation. But we can use the fact that it takes 4 seconds for the baseball to hit the ground, and it was thrown horizontally. We just use the vertical direction. Y is 1 FAT squared plus VIYT. V initial y is 0. So 1/2 minus 10 meters per second squared for the acceleration. The time is 4 seconds. Square that. 16. 16 times 1/2 is 8. 8 times 10 is 80. The ball fell 80 meters in 4 seconds. The height must be 80 meters. That's the answer to part A. Part B asks for the initial speed of the baseball. How do we get that? If we had the horizontal distance, we know it's in the air for 4 seconds. We can calculate how fast it must be going. But we don't have that distance. We have to think, how do we get the horizontal component of the speed? The horizontal component never changes. It's constant. If we know what it is at the bottom, we can get it at the top. To get the horizontal component of the velocity of the baseball at the bottom, we need to know the vertical component of the velocity. What's the vertical speed at the bottom? How fast is it going vertically at the bottom? Well, the initial vertical speed is 0, and it falls for 4 seconds. If the initial vertical component of the speed is 0 and it falls for 4 seconds, the final speed is 40 meters per second. Gravity increases it 10 meters per second each second. So now we know the speed at the bottom is 50, and we know the vertical component of that is 40. We can use the Pythagorean Theorem. So the speed is 50. V sub x we don't know, but we know V sub y is 40. So we can calculate V sub x. It's a 3, 4, 5 triangle. So once we know the horizontal component of the speed at the bottom, that's the horizontal component of the speed everywhere, which means it's the initial horizontal component of the speed. And since the ball was thrown horizontally, the initial speed of the baseball was 30 meters per second. Part C asks for the height at which the speed of the ball is 40 meters per second. How high is the ball above the ground when it's going 40 meters per second? I can't believe this is only the first problem on the test. It's impossible. How do you get that? 40 is neither x nor y. Well, we know that the horizontal component is 30 meters per second all the time. So we can use the Pythagorean Theorem again and set the speed of the baseball equal to 40. That's the hypotenuse, the actual speed of the ball. The horizontal component is 30. So again, v equals vx squared plus vy squared. V in this case is 40. Vx doesn't change. It's always 30 meters per second. So we can solve for v sub y. So v sub y is 26.45 meters per second when the speed of the ball is 40 meters per second. Since the initial vertical speed of the ball is 0, the time it takes to reach a vertical speed of 26.45 meters per second is 2.645 seconds, because gravity increases the vertical speed by 10 meters per second every second, and it started at 0. So now we have the time it takes for the speed of the ball to get to 40 meters per second. 2.645 seconds. The average vertical speed is 26.45 divided by 2, which is 13.22 meters per second. If it averages 13.22 meters per second for 2.645 seconds, it falls a distance of 35 meters. So it fell 35 meters. The height of the building is 80 meters, which means it's still 45 meters off the ground. That's the answer to part C. I hope the next two problems are easier. No, I don't. I hope they're harder. I like hard ones.